Hi guys, today we're gonna talk about gases and the laws related to it. So, what is gas? So, gas is a homogeneous fluid that expands to fill the container and take their shapes, and they have a low density compared to liquid and solids, and they're compressible. So, now let's talk about the kinetic molecular theory. So, there are different parts to it. The first part is that gases are in random rapid motion, and when they collide with each other, the collision is elastic, which means if you have two gas particles and they collide with each other, they're gonna go to their separate ways and they're not gonna stick to each other. And also, the kinetic molecular theory is telling us that there is a lot of space between the gas particles compared to their sizes, and also that the average kinetic energy of the gas particle is proportional to the temperature in Kelvin, which Kelvin equals to degrees Celsius plus 273. Okay, so now let's learn about pressure. So if you're in a container and we have gas particles, they're gonna collide with each other and with the walls of the container. So pressure equals to force that these gas particles exert to the container to area. So now let's learn about units of pressure. So the most important one is ATM, which equals to 760 torr or millimeter Hg, which is mercury, and 101.3 kilopascal. And what is pressure depend on? So pressure is going to be directly proportional to density or concentration and average speed of the gas particles, but it's indirectly proportional to the volume of the container. And based on what pressure is proportional to or not proportional to, we're gonna have the different gas laws. So the first gas law that we have is Boyle's law, that is telling us that pressure is indirectly proportional to volume. So we're gonna have P1 V1 equals to P2 V2. I remember that the pressure should have the same unit and volume should have the same unit when writing it. So if we want to draw a graph of it, and we have volume on the vertical axis and pressure on the horizontal axis, the graph is gonna look like this, which shows as pressure increases, the volume decreases. So now the next law. So then we have the Charles law. That talks about the relationship between volume and temperature. So volume and temperature are directly proportional. So V1 over T1 equals to V2 over T2. And remember that for all of these laws, when we're changing two things, the third one, which is either pressure, volume, or temperature, is going to stay the constant. So for Charles' law, pressure is constant. So if pressure is constant, then as we increase the volume, the temperature is going to increase. And the temperature always have to be in Kelvin, because we can have 0 or negative numbers. So if we have to draw the graph for it, it's going to be like this. And the reason is that when we are in a container and we have the gas particles, as the temperature increases, their average kinetic energy increases. So average kinetic energy is going to equal to 1/2 mv squared. So as this one increases, the velocity increases, which if the velocity increases, then they're going to collide more frequently and they're going to cause this container to expand. So it's going to get bigger. Now, the next law that we have is Avogadro's law. So in Avogadro's law, we're talking about volume and number of moles of gas particles that are in the container. So they're directly proportional, so we're gonna have V1 over N1 equals to V2 over N2. And if we have to draw a graph of it, it's gonna look like this. So, which makes sense, because if in a container we have, for example, 4 moles of gases, and we increase the number of moles and we make it to 8, then the volume has to expand. Because remember that for these one, we're assuming that the other factors are constant. So for this one, the pressure and temperature are constant. So in order to maintain the same pressure, these has to expand, because if not, and we add 4 more to here, then the collisions with the walls of the container is going to be more, and pressure is going to increase. So the volume has to expand in order for the pressure to stay constant. Now, from mixing all of these laws, we're gonna have the final law, which is the ideal gas law. So in the ideal gas law, we have PV equals to nRT. So in PV equals nRT, P is going to be pressure in ATM, and this V is going to be volume in liters. And as we said, for gas laws, the temperature always have to be in Kelvin, because we can have zero negative number for our gas laws. So it has to be in Kelvin, which is for temperature. And N is going to be our number of moles. And R is going to be our constant, which is 0.0821. As law, we have PV equals nRT. And the number of moles is going to be the grams that we have over molar mass.
Yep.
So now we can substitute N with those two. So it's going to be PV equals, I'm going to say mass with little m over n RT. And what's density? Density is going to be grams over volume, so it's going to be m over v. So for finding this, we're going to put v on the other side. So it's going to be P equals m over v times RT over m. So now this equals to density, so it's going to be Pm over RT equals to density. So now a summary of all the formulas that we learned. So for Boyle's law, we learned that at constant temperature and number of moles of gas, we're going to have PV V1 equals P2 V2. And then we also know that V1 over T1, based on Charles' law, equals V2 over T2. And based on Avogadro's law, we learned that V1 over N1 equals to V2 over N2. And we finally learned that ideal gas law is PV equal to nRT. And by deriving density from it, we're going to have density equals to Pm over RT. Thank you.